Welcome back. In this video, we will look at R programming. There are two ways that you can write your code and execute it. First is just using the console pane where you can write the code that you want. For example, we can write a code like print and then we say hello world. And all you need to do is just write there and hit OK. And we see that the output is just below whatever you've typed in the console. But now imagine you had a big project where you want to write a program that is you can run over and over again. Remember, this is line by line. If you write in the console, it's just line by line. And for you to go back to that piece of code or line of code, you have to press the up arrow, just go back to the previous code that you've written. That's actually not a very good idea because you might want to run a piece of project over and over again. So in which case, you need something we call RScript. And basically, RScript is where you can write your code line by line and you can actually save it as well. And you can run the program anytime you want. So there are various ways you can start an R script or a new R script. First, you can go to File and you point to New, and then here you have various things that you can start. In this case, we want R script. And once I click on it, we see a blank R script that appears, and this is where you can write your program or your code. That's one way you can start it. I can go ahead and just close it just to show you another way that you can start it. Here, you can use a combination of keys on your keyboard to start it. And you can say Control plus Shift plus N. So that will automatically start a new R script and you can write the way you want. You can write the code that you want. So once we have it open, we see that we have untitled, meaning that it's not saved. So we need to select an appropriate place to save it. And to save it, you just go to File, then you say Save As, and then you can navigate to the location that you want to save the R script. In this case, I'm going to select A, and then we can create a new folder, call it R tutorial, and we can call it open the folder. Then inside the folder, we can call it my R script, and you can just hit save. So once you save it, we see that it has an extension called R. And if you point it, you can actually see that it's saved in that location, drive E, in a folder called R tutorial, and the name of that script is called my R script. So now that we have our R script there, we can write and execute code here. So first, we need to have some comments explaining what your code is about. So for example, you can say this is my first R script, and you can say this is a comment. And basically, it means that a comment will start with a hash, and a hash just tells R that anything that comes after that, it's a comment and just be ignored. But if you write something like print, and then you say maybe hello world, what will happen is that now R will recognize this to be a code. It's the same as what we had done here in the console. The only difference is that this will remain there and I can execute any way that I want to execute. So how would I execute this? There are several ways that you can run anything on this script. The first one is you can click on this run button here, and pointing at it, you see that it's going to run the current line or selection. So you can either just make sure that your cursor is on, you click on that line you want to execute, and then you hit on the run button. And as you can see here, just down here, there's a print statement that appeared, the code and the output. That's one way. You can as well select maybe several lines of code or maybe one and hit on the run button. That's one way to run. The next method is using Control Enter. I can make sure that I click on that line, and then on the keyboard I hit Control plus Enter. That will again run that piece of code. And there's also another way that you can run the script, but not just a single line, but the whole script. And to run the whole script, you only need to use your keyboard, and you press Control Shift and then Enter. We see that using that Shift Control Enter, we've actually run the whole script. So you've executed the whole script from top to bottom. So basically that means if you want to have a program, you have to run it from the first line all the way down if you use Shift Control Enter. And if you want to execute maybe several lines, you just select them and hit Control Enter. Alternatively, you can simply copy the lines of code that you want to execute and paste them in the console. If I paste this, I see that I have all those lines, and to execute, after pasting, you just hit Enter, which means that you've already executed everything there. And as you can realize here, that once you execute you copy and paste a number of lines, each line will be executed on its own after this right pointing arrow. So we have 3 lines of code that have been executed, including the empty lines that we have here. This is an empty line, this is another empty line. So it has been executed. So it's like skipping some blank lines. And that's the way you can actually execute some R code. There's something that is so fundamental when you are you're using R. It's very important to make sure that you manage your files and projects. For example, you've actually saved an R script. That's a file, .r file. So if you see here, we have on the bottom right corner, we have the file section, the plot section, but now we need to manage all this. You need to manage all this, and you might want to know where your working directory is. You can just type pwd, path to working directory. Anyway, so in this case, you can create a new folder by simply just coming here and you click on new folder, and you can call it maybe Matthew folder, and we see that the folder has been added just here at the bottom. You can also set your working directory folder, and to set your working folder, or maybe to make sure that you are connected to your working folder, there are 2 ways. You can go to session and then go to set working directory, and you can choose either to the source file location or the file pane location, or you can choose your own working directory. In this case, I'm going to choose my working directory, and here we can go to the folder that we created, and we can actually click on maybe Python tutorial. Now, let's just use the R tutorial. That means that I have another tutorial for Python. You can go check it out. It's a very good place to start if you want to learn Python. So I have a comprehensive tutorial on Python. So you can go watch, like, and share. And please do remember to subscribe as well. So I select the working directory to be this folder and click open. Once I open, now I can see the folder that I'm working on here on the right pane here. So anything that I add or execute, it's always going to be here. And this is now my working directory. There's also another way that you can set your working directory, and to do that, you can use the function called set working directory, and in that working directory, you need to select the folder path. And in this case, actually you can see that when it was executed, this is actually our working directory. So I can just leave it as this. So what happens is that set working directory, set wd, is a function which takes the argument which happens to be the directory location. So if you execute this, you can hit Control Enter to execute that. You see that has been executed. You can change this to whatever you want, but in that case, we only have two ways of setting working directory: through session, and then you point to set working directory and you can select whatever you want to set. Another way of ensuring that you're working in a specific folder, you can actually close the script, the R script, and then you say File, Open, and then you navigate to your script that you want to open. Once you open it, it's automatically the folder from which the R script was located automatically becomes our working directory. So, and basically we've looked how you can manage your files and projects and how you can write and execute code. Briefly, we are going to do more than this. The next thing we can check is how to access help and documentation. In most cases, you might forget something and you want to get some help. The best way to access the documentation or help is by simply going to this pane, the right bottom pane, and you can click on help, and you can see you have resources, we have the manuals, we have references, miscellaneous material, help on RStudio, and so many other things. So you can click on anything that you want to understand. And also, you can use a piece of code to help you know what you are looking for. For example, we've actually used a function here called print. But what if you didn't know how to get help? You don't know what it means. So you need to maybe search for an explanation. So in this case, to get help, you can use this piece of code. You start with a question mark, and then you write the name of the function that you want to get. So if I execute this, we automatically see Control Enter. And once you execute question mark print, you see on this pane here, you'll see the help for the print function. I can simply say prints its argument and returns its invisibly. So basically, we can get whatever we want to get using question mark and then followed by the function. Another way is to use the function called help. And inside the help function, you can pass the name of the function that you want to check. For instance, you can check set wd. If I execute this, Control Enter, it shows you what you're supposed to do in the case where you want to get to set the working directory. So this is the help. It gives you a detailed explanation of what the function does. And just like that, we've actually had a look at how RStudio works, how you can write reproducible code, how you can run a piece of code, how you can get help, etc. Next, we are going to look at R syntax and commands. And the first thing we are going to look at is the basic arithmetic operations. You can just clear the R script and have a comment for that. There are several basic arithmetic operations that we can have. The first one is, of course, addition. And to do some additions, we can simply say something like 20. We use addition operator, maybe 30, and you can execute that. And we see that the addition is 50, 20 plus 30, as you might have expected. You can do subtraction. you can have 50 minus 25. We see that we get 25. So meaning that you have to use the subtraction operator or minus. We can also do multiplication. I can say maybe 50 star asterisk with 30. You execute that, you see we get 1500. So meaning that for multiplication you use asterisk. We can do division. For division, you can say 1000 divided by maybe 20. Executing that, you get it's 50, as you might have expected. Using this forward slash, we get the division. You can also get exponential. And to get exponential of a number, we use maybe let's say 30 raised by 20. We get a very big number, as you might have expected. 30 raised by 20 is a very big number. You can change it to a small number so that you see that you get 900. You can also get the remainder of a number using modulo. And modulo is simply double percent signs between the numbers. For example, you might get the remainder of maybe 99 divided by 2. Of course, we expect that the remainder after dividing 99 by 2 would be 1. And that's basically some of the common basic arithmetic operations that you can perform in R. Then the next thing you are going to look is variable and assignments. In this case, as you can see, we are just doing mathematical operations or basic operations here, and the answer or the output is not being stored. And basically, we need a variable to store either a number or an output from arithmetic operations, or maybe something else. It could be storing a character, text, or anything else that you can think of. So I'm going to clear this output, this our script, and we can have a comment showing that we are looking at variables and assignments. And to assign a variable, we can say something like var variable, maybe 1. You assign it with left pointing arrow and a hyphen, and you can type any value that you want. For example, you can say 350. So basically what is happening here, the value 350 is being stored in memory location of variable named var1. So basically we can say we are assigning this value 350 to a variable called var1. We can also perform some operations, performing operations on variables, operations, variables. For example, you might decide to assign another var2, and you want to assign the value of 350 or var1 maybe multiplied by maybe 6. So if I go ahead and execute this line of code, you can say Control Enter to have, you can see that we have in the environment pane, you can see that we have a variable called variable with its value 350, and we can use the variable 1 to perform some calculations, and the calculation is stored in memory location called var2, which is the variable name. If I execute this, I see that now we have another variable in our environment called with the value 2100. Also, you can actually perform a mathematical operation using two variables. You can say maybe, for example, var3 is assigned maybe the product of 1, you multiply it by var2, or maybe let's use minus in this case. So we can go ahead and execute. So we have a negative 1750 as the value assigned to var3 or variable 3. So that's how we can assign variables and perform some operations. So the next thing we can do, you might want to do some printing. So to perform printing of some output, what we do, can have a comment there. printing outputs. Assuming you wanted to print out the value of variable 3. How do you do it? So you can simply come and say print. You use the print function and then you pass var3 as an argument inside the print function. If I execute this, I can click on inside on that line and click on the run function here. As you can see, it's saying run the current line or a selection. So you simply click on it and you see that the value of var3 is negative 1750. You can print any other variable. So this can be maybe 2. The same way, we see that the value of variable 2 is 2100. And maybe just a recap, we see that we've been using the hash sign and we write some text. And for those lines that don't have the hash at the beginning, they are being executed. But this one, for example, variable and assignment is just a comment. So basically that's how you do commenting. So this is a comment, this is another comment, but this is taken to be a piece of code. There's something else that you should note. We can write a comment as on individual line, or you can decide to write a comment after the piece of code. So you can say, for example, this is a print statement, and if I execute this, control enter, yes, the comment will be displayed there with the print function there because it's the technically what we are trying to execute, but the only output we get is the value of variable 3. So this is another way you can write the code. The comment, it can come after a piece of code. In some cases, you might want to clear the console such that sometimes it gets too long and you don't actually need to see all these output. So if you want to clear it, the easiest way to do it is simply hit Ctrl plus L. Ctrl L will automatically clear the console just like that. I hope you've seen that. Next, we are going to look further into objects, their modes and attributes. The first thing we are going to look at is mode and length of an object. And to check the mode and length of an object, suppose we have a vector z, which happens to be numeric, and we wanted to check the mode. We use a function called mode, and we pass z as our argument. And if you wanted to check the length, we simply use a function called length, and we pass z as our argument. We can go ahead and print out the mode of z and the length of z. So if you execute this block of code, we see that the mode of z is numeric and the length of that numeric vector is 10. Now, suppose that you wanted to change the mode of an object, or rather a vector. What you do, we do something we call coercing to a different type of vector. For example, we have our numeric vector z. If you wanted to convert it to character, we use a function called as.character, and then we pass our numeric vector z. So what this will do, it will simply convert 0 to 9 into character, which means that each number will be enclosed in double quotes, which means it's now a character vector. We can actually convert it back to integer vector or numeric vector by simply using integer as.integer, and then we pass our character vector there as an argument. If I print this out, I see that I go back to our numeric vector or integer vector. Further, we can do some further changes to the mode. For example, suppose that you had a logical vector with true, false, and true as its values, and you wanted to coerce this logical vector to character vector. So what this will do, it will simply convert the logical vector into a logical string. You can go ahead and print this out. Executing this, we see that we have our logical vector, but the vector, the Boolean values have been enclosed in double quotes. So which means that it's no longer a logical vector, but rather a string character. So this is just a normal word, true, has no particular meaning. So again, we can coerce the character vector with true and false back to logical vector. And how to do this? We simply use as.logical, and then we pass our character vector as an argument. So if I execute this, I get a logical vector again. In some instances, you might want to create an empty object, and then you can add elements later or values later on. And to create an empty numeric vector, we simply use numeric function and you pass no arguments. So in that case, you simply get an empty numeric vector. Similarly, you can create an empty character vector by simply using the character vector and you fail to pass any argument. So in this case, if I execute this, I get an empty character vector. And now suppose you wanted to change the length of an object by adding some components or some elements. For example, in our empty numeric vector, we can add a value. And to add a value, we simply use indexing to assign a certain value to a specific position. For example, we can add at position 3 of that empty numeric vector, we want to add 17. And note that we are adding at position 3, meaning that there will be an empty position 1 and position 2, which means what R will do is simply add NA, or basically not available placeholders. So if I execute this, I see that I've added at position 3 the value 17. If I go ahead and print our vector now and have a look at how it looks like, we see that we now have 3 values in that vector, but the first and second one are an S followed by 17 at position 3. And that's basically how you can add an object at a particular place. For example, I can decide I want to change maybe position 2 to be a different number. If I execute and print E again, you'll notice that at position 2, we now have 100 instead of an A, meaning that NA has been replaced with 100. In some instances, you might want to truncate the size of an object. And to achieve that, what you're supposed to do is, or maybe you can have an example. Suppose we had a variable alpha, which is a numeric vector of length 10, has numbers 1 to 10, and you wanted to truncate alpha to length 5, keeping the components with even indices. So, meaning that if you have 1 to 10, and we want only those at position that corresponds to even, meaning that is 2, 4, 6, and so on, what we do, we'll first try to think how we can get those even indices. Therefore, we have to say, like, you create a vector 1 to 5, and then for each number multiply it by 2, meaning that you're going to have even numbers between 1 and 10. And since we want to have the corresponding values at those even positions, then we have to do indexing. So we have to have our vector alpha, and then we open square brackets and we pass our even vectors or even indices. If I execute this and print out alpha, you get 2, 4, 6, 8, and 10. So which means that we've been able to get the even numbers between 1 and 10. And sometimes you might want to change the length or just to truncate and get a number of values in a vector. So in this case, suppose now we set the length of alpha to be 3. We know that alpha now has 5 elements, or maybe you can just go back to our original one. Original vector alpha is 1 to 10. I execute that and I set the length of alpha to be 3 and print out our length, or I'll print out our alpha. You'll notice that now our alpha has the values 1, 2, and 3. The reason is because once you set the length, is going to truncate anything that's beyond the length of the vector that you want with missing values. Suppose now we had a vector of length 5, which can be created using numeric function and passing a certain number in there. In this case, we create a numeric vector of length 5. Suppose now we wanted to extend that vector. Remember, it's of length 5. We want to make it to extend it to length 7. So to do that, we simply use indexing by assigning an a to this index, which is extend vec. Then we pass 7 in the square bracket, and we assign an a. What this will basically do is simply extend the vector to length 7, adding missing values at index 7. So if I go ahead and print this out, I get, I can just copy that and paste it there. So if I execute this block of code, I see that now I have an additional 2 and s at the end. This can work with any number. You can say, for example, you say that this is maybe 10, and you assign it a certain number, let's say 100. If I execute this too, you see that at position 10, we add 100, and anything else before that will become an A. Remember, we had 7, and then at position 10, we added 10, which means that this by default will be added as missing, which means they're going to be not available NS. The next thing we are going to look at is ordered and unordered factors. A factor is a vector object used to specify a discrete classification or grouping of the components of other vectors of the same length. R provide both ordered and unordered factors. We can look at this using examples. The first thing we do, we can create a character vector. This character vector is simply a list of states, some of which have been repeated, and these are territories and states of Australia. Now, to create a factor, we use a function called factor, and we pass our character vector as an argument in the factor function. We can go ahead and print out the factor. So by executing the code, we see that the print function treats the factors differently. We see first it's going to print out the list or the character vector, and just below it we have the levels. We see what R did is simply took the character vectors and checked the unique sets and ordered them in ascending order alphabetically, and that's how we have this as the levels. And this is a good example of unordered factors. To get the levels of a factor, we use a function called levels, and we pass state f. So if I execute this, I get the levels in that factor, which are simply the unique territories and states in that character vector. So how would we use this? We said that a factor is a vector object used to specify a discrete classification or grouping. So meaning that we need another vector to use these factors. And to do that, suppose we have a list of accountants and their incomes, and these incomes correspond to these states. For example, the first tax accountant comes from Tasmania, which is TAS, and the income is 60. The second one is SA, comes from SA, South Australia, and the income is 49. So how would you calculate the mean or the average incomes per state? In this case, we use a function in R called tapply. Basically, what tapply does is simply apply certain function that you want to apply to this vector to different groups or levels of a factor. For example, if we wanted to calculate the mean of individual groups of incomes per state, so this is what we do. We use the function tapply, and the tapply will take 3 arguments: the income, our factor, our unordered factor that we created earlier here, which happens to be this one here. And then for each of those, levels, we calculate the mean. So I can go ahead and execute this to see the outcome. It says object income not found because I've yet to execute this, so I can execute the whole block. If I execute that, this is what I get. I get the means for individual states and territories. So we see that ACT is 44.5, New South Wales is 57.3, and so on. And lastly, we have for Western Australia is 52.25. And that's basically how you can apply mean function to different levels. Similarly, you can actually calculate the standard error for the same. And to calculate the standard error, we simply first create our own function, our function of x that takes the values, basically in this case like income, and then we get the square root of variance divided by the length of that vector. And because we want to do this for all or for individual levels, then we need to use the tapply function to apply that function that we've just created to calculate the standard error per state. So we use tapply, we pass incomes as the first argument, and then our factor state f, which happens to be our factors, and the function that we've created to calculate the standard error for a set of numeric values, which happens to be income. So executing this, we see that the standard error for each state and territory is like this. So we see for ACT, we have 1.5, New South Wales is 4.3, and looking at it, we see that Victoria state has the highest standard error. And comparing also to the mean is 56 in this case, and the standard error is 5.2. So that's basically how you can use tapply to loop over factors while computing a certain statistical mean or standard error. This can work even with something like sum. You can get maximum, minimum. You can try, for example, we can get the mean, that's standard error. We can get something like the sum. Execute that. You see we're getting the sum. We can get the minimum, mean. We can get maximum. So basically you are getting all these functions, sum, mean, max, average, standard error, and any other user-defined functions you can apply. Next, we look at ordered factors. And for ordered factors, it's simply those factors that have some sort of order. For example, we can have a scale, a rating scale like poor, fair, good, and excellent. And from this, we can tell that there's some sort of order. There's some levels. We can actually say poor is the worst, and fair is a bit better, good is better than fair, and excellent is better than good. So whatever factor that we create here should be ordered. That's why it's called ordered factor. So to create the ordered factors, we use the word or the function ordered, and then we pass our rating, which happens to be character vector, and then we specify the levels. The levels have to be in the specific order you want them to be in. So we can go ahead and print out the ordered factor and execute the whole block. So we see that once we print, we see that we are getting a bit different output. The levels have some particular order. We have poor, and then followed by less than sign, fair, less than sign, good, less than sign, excellent. Meaning that excellent is the highest in that rating order. How do you check the levels of the ordered factors? To get the levels, we simply use the normal function as we used for the unordered factors. So, and this is the way you do it. We use the function levels, and then we pass our ordered rating or ordered factors, and we can execute this. We see that our levels are poor, fair, good, excellent in that order. So, and we can actually compare with the unordered factors. If you are not careful and did use factor function to get the levels, let me show you how this is gonna compare. if I execute this, we see that our levels now would be excellent, fair, good, and poor. And we know that this order is not correct because we know that there's no way you can have fair being better than good. So we have to use, first you have to ask yourself, which kind of factor do you have? Is it ordered or unordered? If it's ordered, we use the ordered function to create the factors. If it's unordered, then we use the factor function to create the factors. Hope that is clear. Hopefully you are enjoying this tutorial. And if you have any questions, please post them in the comment section. And remember to subscribe and like the video. Hello, welcome back. We are going to continue with this series of R programming. R operates on a named data structure. The simplest such structure is the numeric vector, which is a single entity consisting of an ordered collection of numbers. We are going to look at what numeric vector is, how it can be assigned. The first way you can create a numeric vector, you can go ahead and clear this and as well clear the console. You can say Control L, clear it, and you can maximize. So we're going to look at how to create a named vector. We have several ways to do that. We can use a less than sign and a minus sign following each other. And this is called the assignment operator, whereby whatever is on the left, x, is our variable, which happens to be numeric vector because it's being assigned 5 numbers, and the 5 numbers are inside a function called C. And what happens is that all this number will be concatenated together to form that vector called x. We can actually go ahead and print that numeric vector. So we have to execute, and the easiest way to execute is you can click on this button here, run, or you can have you can use keyboard shortcut Control Enter to run that particular line of code, and we can go ahead and print it out in the console. So we see that we have our numeric vector having the 5 numbers. Another way you can assign a numeric vector, we can use a function called assign function. And how the assign function works is that we have a character, which the first argument is a character enclosed in double quotes, and then the second part is now the concatenated set of numbers. And once I execute this by Control Enter and print out the value of x, we get the same series. So we see that this is the second method you can use to create that numeric vector. And there's also another way, which is not really popular in R, by assignment in other direction. From this step here, we see that x, or the named vector x, is on the left of this assignment operator. We can actually reverse the whole thing and create another vector. Instead of having x at the beginning, we can have it at the end. And now notice how this looks like here. It's been reversed. It's minus sign first, followed by a greater than sign. So this one will still create the same thing. So if I execute and print it out, print x, you still get the same numeric vector. You can also decide to create a copy of a numeric vector, or create a vector by duplicating that vector. For example, we can have our function C concatenating x, which is a numeric vector. Then in between them, we have 0, and then at the end, we have another copy of that vector x. So if I run that and print it out, and just select both lines and execute, Control Enter, we see that we have our first part, this is x, and then you have 0, and then we have another copy of x here. So we definitely made a vector by simply assigning a copy of another numeric vector. And suppose you decided to create something like maybe 1 divided by x. And if you execute this in the console, you'll find the output, but immediately you run that, is not going to be stored because we didn't actually store this. So you have to store it by assigning this output to a named vector. So as you've seen that a numeric vector has only numbers, which means that you can perform arithmetic operations on such vectors. The next thing we are going to look at is vector arithmetic, how to perform arithmetic operations on vectors. In this case, suppose we have a vector, a numeric vector y with 5 numeric numbers, and remember we had our x. Maybe I can just copy this one here and put it here for easy reference. Suppose you have these two vectors and you want to perform an arithmetic operation to get 2x plus y plus 1. So in this case, if you print out this, you're going to get the results of this. So I can execute this, control enter. We see that we get 13.1, 0.5, 20.1, another series, or we can say another numeric vector. And what is happening here, we are taking element wise. So we are taking the value of x multiplied by 2 plus 2.1 plus 1 to get the first value, which is 13.1. And you do the same for each element or corresponding elements in our vectors x and y. You get a resulting numeric vector v. We can also perform some statistical functions on vectors, and some of the popular statistical functions that we can perform, we can say we can get the mean. We can get mean of, for example, x. Executing that, you get the mean is 5.6. We know that mean is simply sum of all numbers in x divided by the number of numbers in that vector. We can also do get the variance. We see that the variance is 7.885. We can also get maximum and minimum. So executing that, we get 9.1 and 2.6. We also have something like getting the range, and as we know, range is simply the maximum and minimum numbers. And we can also get the length of x. It just simply give you the count in that vector. How many elements do we have in that vector? We can also get something like sum, and product. Executing these two, we can get the sum of the values in x is 28, and the product is 3166.844. We can also sort the values in x, and by simply using the function sort, we actually sort by ascending order by default. Also, we can perform some common arithmetic functions on vectors, and some of the common ones that we can use, we can do something like log of x. Execute that. We can also do something like exponential of x, of the values in x. So we see that we get the exponential of each number in that vector x. We can do some trigonometry, maybe sine x. We can do tan x. We can do maybe cos x. We're getting cosine of each. We can also do something like even the square root, sqrt of x, get the square root of each. And as you've seen, we are able to use various functions to perform some arithmetic operations. And the next thing we are going to look at is how to generate some regular sequences. Suppose you wanted to print the number 1 to 30, or create a numeric vector with the numbers 1 to 30. Of course, you can concatenate the numbers 1, 2, 3 all the way to 30, but that would be a lot of work. So we can use a colon operator to do that. For example, here we see that we are creating a sequence from 1 to 30. So what you do, you use a colon operator to tell R that you want the numbers between 1 and 30 to be assigned to a named vector called sequence 1. And you can actually print this out and see what you get. Just copy that there. I should have run that first. So we see that we have numbers between 1 and 30. Also, you can generate a sequence using colon operator with arithmetic operations. For example, if you wanted to generate a sequence between 1 and 30, whereby you only want to include only the even numbers, we can use this command here. It's like you're taking a sequence between 1 and 15, and for each element, you multiplied it by 2. So if I execute that, I see that now I have another sequence 2. I can go ahead and print it out. And if you execute, we see that it's between 2 and 30 in steps of 2. You can actually do something. We can compare some sequences. And to compare the sequences, suppose now we have n is equal to 10, and you want to see how different sequences behave. Suppose we have this. What do you think would be the output for this? Basically, it's 1 to 10 minus 1. So for each element between 1 and 10, you take away 1. So in this case, if I print this out, maybe print sequence 3, so executing both of them together. Oh, I need to execute n as well, meaning that you see that it was 1 to 10, but you subtract 1 from each element. Now, suppose you had some brackets here, such that it's 1 colon operator and then the difference of n minus 1. So you have to be very careful when you are performing your arithmetics, because this would be first, because we know, of course, that brackets take precedence over the colon operator. As you've seen here, we first generated a sequence between 1 and 10, and then you subtracted 1. But in this case here, we are first getting the difference between n minus 1, which is 9, and then we generate 1 to 9. And we can prove that by printing out sequence 4. So let me run both lines together. Control Enter. It's 1, 2, 3, 4, all the way to 9. So make sure that you are careful when working with this while generating sequences. Also, we can actually generate a sequence backward. And to do that, we still use this, the colon operator, but make sure that the maximum number is on the right side of, on the left side of that, of the colon operator, meaning that you're going to have 30 first and then colon 1. I can go ahead and print this out for sequence. So by executing these two, I see that now I have a sequence which starts from 30 all the way to 1. Also, we can actually use a sequence function seq to generate the sequence. So this is actually the second method. We use the seq function or sec function to generate the numbers between 2 and 10. So I can actually print this as well. Executing both, we see that we are generating numbers between 2 and 10, and 2 and 10 are inclusive. We can also generate a sequence with specified steps using the seq function or sec function. And how to do this, how to do that, can minimize a little bit. How to do that, we only need to include by equal to the number of steps that you want in the seq function as one of the arguments, that is. So you want to generate the numbers between -5 and 5. By default, this is a step of 1. This is a step of 1. But if you want a varying step size, you have to use the argument by equal to whatever number you want. In this case, it's 0.2. We can go ahead and print out a string. So we see that we are getting -5 all the way to 5, but with a step size of 0.2. Also, we can generate a sequence with specified length using the step sequence function. And to do that is actually very easy. Here, we see that we're using the sec function. The length is 51, and you specify the starting point where is -5, and you want it to have step size of 2. So what will happen is that it will start from -5. That will be the first element you have in your vector, and then you add 0.2 to get -4.8, and then it's gonna loop until we get a vector of 51 elements or numbers. So we can actually go ahead and print S4. So executing that, we see that we have, it's coming to, it's just simply the same as this one. This one had 51 numbers. You can go ahead and count, but, or maybe you can just use maybe 5 to make it easier for us to see. So we see we have 5 numbers starting with -5 with step of 0.2. We can revert it back to our 51. Yep. And then also we can generate a sequence based on the length of a vector using a sec function. So in this case, we might have a vector, an existing vector with values 1, 2, 3, 4, 5, and then we want to generate another sequence that will follow the same format as 1, 2, 3, 4, 5. We can do it this way. We can create another sequence 7 sequence function along equal vector, which in our vector is simply a numeric vector with numbers between 1 and 5. We can go ahead and print this out. Print sequence 7. Execute this. I have to select all the 3 lines and execute. So here we see that we created another vector with the same numbers 1, 2, 3, 4, 5. And suppose we had something like maybe comma 8. Let's see. After changing that, what do we get? We see we get 1, 2, 3, 4, 5, 6. So what happens here is that it's just counting the number of elements or numbers in that vector, and it generates an equivalent, or it generates a sequence starting from 1 at a step of 1. That's why we are getting 1, 2, 3, 4, 5, 6, meaning that it's counting the length, it's taking the length and generating a sequence of length 6 with a step of 1 beginning from 1. So in some instances, you might want to replicate an object using a rep function. A rep function, what it does, it just tells R that it wants a specific vector replicated a number of times. So in this case, suppose we had a vector called is a string character or a string vector or a character vector called hello, it's X, and now you want to get this hello multiplied, repeated a number of times. For example, we can say we want it repeated 5 times, and we can print S5 and execute. So here we see that we have a resulting vector with the word hello repeated 5 times. That's 5 times. So also you might be able to replicate elements of an object using rep function. But instead of using times here like we did here, we can use each. Let's see the difference between the two. So we can go ahead and print S6. If I print this out, execute, what do we get? We get the same thing. This is hello 5 times, and this is replicated 5 times. So generally what is happening here, because we have a vector with only one word, that word is replicated 5 times each. But suppose now, instead of having that, assuming you had X to have two characters, maybe this, maybe world, there, and close. If I execute this, we have a different X with 2 words. Suppose now I execute this, repeat it 5 times. Let's see what happens. So it just replicated hello world in that order 5 times. Hello and world in that order 5 times. But if I use each, let's see what happens. We see what each does, it just replicates each word 5 times. Once it finishes with one, it goes to the next one. So we see that we have hello 5 times and world 5 times. And that's basically, you can say we are done with the numeric vector, as well as a few examples of string characters. The next type of vector we are going to look at is logical vector. For this vector, the elements can either be true, false, or NA, in the case where the values are not available. We can kick it off by first creating a logical vector using a condition. Assume that we have a numeric vector with 5 numbers, 5, 10, 15, 20, and 25. If you want to generate a logical vector with true where the value of x is greater than 12 and false when the value of x is less than or equal to 12, we use this condition. Basically, what's happening here, this will just return whether it's false or true, and the resulting vector is assigned to a variable called temp, and that vector that has been created is the one we are calling a logical vector. We can go ahead and print it out, and when you execute that, we see that we have a vector that has either false or true. There are several logical operators that you can use. You can have maybe greater than or equal to. You can have less than or equal to, equal, and so on. Now, what if we combine two logical vectors? What would happen? Now, in this case, suppose that you had two logical vectors, one checking whether the value is greater than 10, and the other one checking whether the value of x or the elements in x are less than 22. If you want to combine C1 and C2, we use what we call intersection. So here, the intersection means we are taking C1 and C2. That is intersection. We call it intersection, and we can also say it's called logical AND. So if I execute this, we see that the intersection is false, false, and true. Maybe what I can do, I can print C1 and C2, maybe C1, print C2, and I print intersection. It's false and true becomes false. If it's true and true, it becomes true. Another possibility is where you want to use OR. If you're checking the logical OR, it's like you're taking the union of C1 and C2. And for C1 or C2, what would happen in this case? I can print this out. You see that everything becomes true. There's something else we call negation. Negation is just a reversal of whatever the logical vector it was. If it's false, it becomes true. If it was true, it becomes false. That's why if I do this, I get true, true, false, false, false. And then also, you can use logical operators in arithmetic operations. And basically what this will do, it will just coerce logical vectors to numeric. We can do it as an example here. So you have C1 plus C2. So if you're adding, that means that this will be coerced first, basically conversion from a logical vector to a numeric vector, and then summation will be done. In this case, what will happen is that the first value, you can have it here, C1, the first value would become 0, and C2, the first value will become 1. So it's like you're taking 0 plus 1, and so on. So that's why you're getting a numeric vector, because the booleans have been converted to numeric, and a normal addition happens. That's why we're getting a numeric vector like that. The next thing we are going to look at is missing values. So for example, you can have a vector with some missing values here as the first, second, the third is missing, and fourth and fifth are available. So this will simply create a numeric vector with these values, and executing that, you see that we have created a numeric vector with some missing value like that. Now, suppose you wanted to check if there are missing values in a certain vector. So what you do, we use a function called is.na, and then inside the bracket we pass our vector. So we use that function and we check whether there are NAs in Z. So what will happen, this function will go through each element and check, is it missing? Is it NA? True or false? So it's going to return a logical vector with true or false. So we can go ahead and execute this. So here we see that we have false, false, true, false, false, because the third element is false, is NA, meaning that it's missing, hence being true. So also we have another category of missing, but it's not particularly missing, but it's not a number. So how do we deal with not a number, NaN? So here you can create a NaN, two of them. The first NaN is when you divide 0 by 0, you get not a value, not a number. Also, if you want to get a square root of a negative number, of course, we expect to have an error, meaning that whatever the result is going to be not a number value. So if you print this out, because you expect to have NaNs, you see, it's actually even giving you some errors, warning, square root of negative number produces NaNs. And we see those are the values there. And you can check whether you have NaNs or NAs. For example, the same way we checked for this NA, we can check for NaNs. The same way we did that, we can check NaNs by simply adding an N after the Na, and we pass our vector that we want to check whether they are NaNs. If I execute those three codes and check the outcome, you see that the first one returned a vector whereby when there was a presence of NA becomes true and false when the elements were not NAs. And likewise for these two, if there's there's NaN present, then that will be returned as true. The same as for the NaN check number 2. The next thing we are going to look at is character vectors. So here, character vectors is when we have characters as opposed to numbers. In some instances, you can have numbers, but they are considered to be characters. I'm going to explain further. So the first thing we do, we can create character vectors in two different ways. We can either enclose some numbers or some characters or some words in double quotes, both sides, or it can be a single quote. You can go ahead and execute this. So we see that we have the first character vector and the second character vector. And then we can concatenate character vectors. You can take two and concatenate them into one. For example, you can do this. You can have two characters, two different characters or strings, and then we concatenate them using this C function into one. If I execute this, you see that we have one vector, but with two characters, two strings that has been concatenated to form one vector. Meaning that in here, our vector has two string characters, two set of string characters, that is. Also, we can use a function called paste. And for paste function, what that does, it will just take the first argument to be a string character, and then you can have a sequence 1 to 10, and you can have a separator. So you have x1, y2, x3, y4, Maybe I can just print it out for you to understand. So this is what you get. X1, Y2, X3, Y4, all the way to Y10. And the separator is a blank. And if I decide to change this, for example, to a space and execute again, you see we have a space between the string character and the numeric character. And that's it for the string, for the character vectors. The next thing we can have a look at is how to index vectors, or basically selecting and modifying subset of a data set. So for example, suppose we have a vector with 5 numbers, but one of them is missing, and we wanted to select non-missing values. So to select non-missing values, we need to come up with a way of checking whether a value is missing or not. So in this case, we will use this. So this first part, this will just return a logical vector having true or false. And because it's being negated, you see this exclamation mark here? It means that it's negating whatever the logical vector was. So in this case, we expect to have a false when an A is present. And whatever the outcome is, we enclose it in square bracket. And we can go ahead and print out and have it, can have a comment first there, and then we can print out the value of y. So basically, we are going to get the values of non-missing values, a vector of non-missing values. So it's like we just removed our NA from that list. And also, in some instances, you might want to select values from a vector that has been arithmetically manipulated. So, for example, you might want to select values from x plus 2, meaning that all the values of x has been added to that are non-missing and greater than 5. So here we have different conditions we are checking here. The first one is this one. It's the values are non-missing, and remember the logical and. Another condition, the values are greater than 5. So if I execute this, we get 9, 14, and 17. The next thing we can do, we can select a subset using positive integral index vectors. Let me show you an example. Suppose you have our vector x with these values. You see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values, 2 to 20, steps of 2, and you want to get this subset. What this will do is just take, that's our vector, and then we use square brackets, we pass the position. This is actually position number 7. So we expect the value that we are going to get, or the number that we are going to get, is in position 7. We can count 1, 2, 3, 4, 5, 6, 7. So we expect to get 14. Let's go ahead and execute to confirm that. Yes, we get 14. Also, we can select a range. And to select a range, you can select elements at position 1 all the way to 5. So if we execute this, you see that we are getting the first 5 elements, meaning that you selected from 1 all the way to the one at position 5. Also, you can actually create a subset, a repeated subset of maybe 2 items, say apple and banana, and you want it repeated in this form. How many times? 5. If I execute this, you'll see that apple and banana has been repeated 5 times. And actually, you can even play with this again. For example, you can say, instead of times, you can have each. And in this case, it will become a bit different, because apple will first be replicated or repeated 5 times, followed by banana 5 times. But if you use times, you realize that they'll be repeated in that order: apple, banana, 5 times. Also, we can select a subset using a negative integral index vector. Suppose we had a numeric vector with these values, and if you do this, you enclose -3 all the way to 5, and we have a minus here, what we will do to simply exclude the values from 3 to 5. In this case, it's going to return this vector, but it's going to exclude anything beyond this. So it's going to exclude this. So we expect to get 1 and 3. We get 1, 3 because anything else has been excluded. Also, we can select a subset using character index vector. For example, suppose you had a numeric vector with 4 numeric numbers, and we have a number of fruits such that you are naming the names of the fruits is oranges, banana, kiwi, apple and kiwi. So meaning that this has been named orange, this is named banana, all the way to this being named kiwi. You can actually select elements by their names. So for example, if you wanted to select apple and kiwi, we only need to pass a character vector inside the square bracket with the names of the subset that you want to select. So if I go ahead and print lunch, we get apple to kiwi is 12. So we've been able to select a subset using the character index. And the character index vector is this one. This is what they're referring as character index vector. Also, you might want to modify a subset using an index vector on the left side of an assignment. For example, if you had a numeric vector with a missing value and you want to replace this missing value with a value, an actual number, basically replacing a missing value with maybe a number, say 1. What you do, you first select that value that you think that is going to be an A. So what this will do, this will simply select the value where the value is missing in that vector, and you assign it a number 1. If I go ahead and print X again, you realize that the value of NA has been replaced with 1. See? Yes. We see that the missing value has been replaced with 1. And that's how you can actually replace any value. It doesn't have to be NA. It can be something like, for example, you say X, you select, say you want to replace number 4. And what do you want to replace it with? Maybe 1,000. If I execute this true, you realize that whatever was at position 4 in that vector has been replaced with the value 1,000. Also, you might want to replace negative values in a certain vector with absolute values, meaning that anything that was negative, you wanted to become positive. And suppose you had a numeric vector with some negative values and you wanted to remove the negatives. So what you do, you are supposed to just select those values that are less than 0. So this will simply return either true or false. But if you are subsetting, if you subset, then it's going to take anything that is true. So this one will only return anything that is less than 0. So in this case, you go ahead and, for example, if I execute that and execute this bit here, you see that it's only selecting anything that was negative. So if you want to replace those negative values with positives, we can actually use a function called ABS, absolute. ABS will just replace, will just get the absolute values of anything that was negative, which is this. So if I run this command and print out the value of y, you realize that anything that was negative has been replaced with positive, a corresponding positive value. And that's it. Oh, so basically what happened here, I need to execute this, and then this one, I need to use the proper assignment operator, less than and then minus, and you assign an absolute value of whatever it was. So if I execute this, I get 2, 4, 6, 8, 10. So anything that was negative has been replaced with a corresponding positive value.